with yesterday.
Part two, yeah. So, you're still talking about it with Miss Soban, but today we're just going to be looking at the plate boundaries specifically. And we're going to do a little activity later on, like I mentioned yesterday, testing out each of the boundaries so you can get an understanding of how they actually work on the plate's crust. So, begin with a little, actually, back to yesterday's list that we started. You remember the list? So is there anything that you'd like to add from the list from yesterday and then the plate boundaries that we talked about? So we have one plate boundary up here. Do you remember the other two we talked about yesterday? A little bit. I just mentioned them, but we're going to be looking at them more today. Or is anything else with plate tectonics you want to add to this list?
Is it tropical plant and Antarctica?
What?
The tropical plant and Antarctica.
Tropical, what did you say? Sorry.
Plant?
Plant?
Yeah.
Okay, yeah. Anything else?
Ridges.
Awesome. Yep, the ridges. Do you know where the ridges were located?
The main one was between South America and Africa.
Mm-hmm. That ocean ridge, right?
Yes.
Yeah, awesome. Yep, Mid-Atlantic ridge. Good, good. Awesome job. Okay, is there anything else we want to add?
Mantles.
Mantle? Is that what you said? Or what?
No, you just like finishing what you're saying.
Yeah,
Oh.
it said mad.
Oh,
It
yeah.
said mantles.
Yeah.
First.
Yeah, I'm spelling this all wrong, aren't I? No, but this is a good list. We're going to be adding to this list for the rest of the week.
Yeah.
But, what?
I was about to say we can put mantle, but we already have mantle on here.
Oh, we do. Yeah. Perfect. Awesome job. Yeah, so we'll add more to this list for the rest of the week. But today, specifically, we're going to learn more about those boundaries, the plate boundaries, and then do the activity later on. Sound good?
Mhm.
Okay. So, first, we're going to be watching a video talking about the 3 boundaries we'll be looking at. It's a quick video just to give you a little bit more information about how our plates are moving.
Some of the most dramatic changes in the Earth's crust, like mountain ranges, new islands, or earthquakes, occur along plate boundaries. There are 3 types of plate boundaries: divergent boundaries, convergent boundaries, and transform boundaries. Convergent boundaries occur when 2 plates collide. There are 3 major types. First is continental to continental. This occurs when 2 plates of continental crust collide. They buckle and thicken, and this causes mountains to form. Next, you have continental to ocean collision. When a plate of ocean crust collides with a plate of continental crust, the ocean crust is more thick and subducts or goes underneath the continental crust. The magma from the melted oceanic crust rises to the surface, and this results in volcanoes along the boundary. Ocean-to-ocean collisions occur when 2 plates of oceanic crust collide. The older, more dense plate subducts under the younger plate, and as a result, the crust melts and creates an island arc. Next, you have divergent boundaries. This is when 2 plates move away from each other. The separation allows the asthenosphere to rise towards the surface and partially melt. This melting creates magma, which erupts as lava, and then the lava cools and hardens to create new rock and ocean floor or new continental crust. As the crust and upper part of the asthenosphere cool and become rigid, they form new lithosphere, like mid-ocean ridges. Most of these divergent boundaries are located on the ocean floor. However, rift valleys may also form where the continents are separated by plate movement. And finally, transform boundaries occur where 2 plates move past each other horizontally. When the plates move next to each other, they they do not go along smoothly. Instead, they scrape at each other in a series of sudden slippages of crustal rock, and these can be felt as earthquakes. Unlike the other types of boundaries, transform boundaries generally do not produce magma. The San Andreas Fault in California is a major transform boundary. So there we go, 3 types of plate boundaries: convergent, divergent, and transform.
All right. So those are 3 plate boundaries we're going to be talking about today and for the rest of the week. I'm going to write all 3 up here. Divergent. Convergent.
Then there's transform.
Awesome. Yep. Transform. All right. So using arrows, would someone like to come up? So using arrows as your plate boundaries. So 1 plate and 1 plate, however arrow shown in the video. Did you see the pictures of the arrows? Does anyone want to come up and for each one, or just do one? Show us the way which the plates are moving. Want to come up? Do which one? You can do whichever one you want, but just draw with arrows the plates and which way they move.
I'm just gonna make an example.
Oh yeah, you're gonna draw the plate. Awesome. Awesome, yeah. So those transform boundaries, they're touching, right? Just another way so you can see it, but you should notice with the plates. One's going this way, one's going that way, like horizontally. Yeah, great job. Yep, so they're sliding past each other back and forth. Great. All right, does anyone want to do convergent or divergent? Want to come and test it out? Anybody?
I don't remember.
You don't remember? It's okay.
I think I remember transform, but I don't remember the other 2.
Okay. Convergent, what does it sound like? They're
Converting.
converging. Yeah.
They're
So they're
converting
coming-
into a mountain.
Yeah. Yeah, so how
They're
would they?
this way.
Yeah, Lucas did it. Yep, yeah, they're coming together. Awesome. Yep, so
Then
the arrows
divergent
are like
is
that.
Then divergent has the word divert, which sounds like divide. So they divide into like different parts, so
Oh,
they move
good,
away
yeah.
from each other.
Yep, they're moving away from each other. Great explanation. Yep, so they're diverging apart, separating. Yeah, awesome. So like same with what Austin drew. If you drew them, 1 plate here, 1 plate here. They're sliding towards each other. Right? Same thing with divergent. Plate here, plate here. They're separating. Great. Okay. That's just a little list you can have so you can see a visual. But now we're going to be doing a little
Some of the most
So yeah, here's your examples. Your transform boundary is the boundary between the tectonic plates that are sliding past each other horizontally, so like up and down like this. Convergent boundary is the boundary formed by the collision of 2 plates. And like Lucas showed us that the plates were going up like this, or building up that mountain range. Yep, great job. And the divergent boundary is the boundary between 2 tectonic plates that are moving away from each other. So they're
And it's the tree, the bamboo, and the beehive.
yes. Yeah, the cute little pictures at the top. All right. So now we're going to be creating our own boundaries with a little snack. Hand out each plate.
Why would you be a peasant?
Alright. And then you'll get some whipped cream.
Is the whipped cream meant to be like the
Yep. That's exactly what it is. Say it louder so everyone else can hear you. What is it?
So basically the whipped cream is gonna be like the magma.
Mm-hmm. Yep. The magma. That is. If it was red, it'd be a little better. But
Red
Yep.
food coloring.
yep. So I'll put a little dollop on everyone's plate.
2 spoon scoops.
Mm-hmm.
be even. Like the video said, the oceanic crust, the ocean crust is like way more thicker than the continental.
Yeah, but this is our magma, right?
Yes.
Yeah. So what do you think the crust is gonna be?
Those
ground
crackers.
Yeah.
It just looks like the plate was painted wrong.
Yeah, I saw someone do this with shaving cream, but that's not as fun, right?
Plus it makes the cookie after not edible.
Yeah. No, you wouldn't want to eat that.
No,
Eat it.
shaving
That's
cream
the whole point.
doesn't sound good to you, Joey.
Looks like sour cream.
Sour cream and onion.
That'd be a good April Fool's joke.
Mm-hmm, sure would.
So there's your whipped cream as your mantle, or as you talked about with Soban last week or 2 weeks ago, the layers of the earth. That, on the last slide, told us that the mantle is also known as the, it's not on this one,
That way you went back.
asthenosphere, right? Your magma, where your graham crackers are your earth's crust, which is the lithosphere.
Oh, well,
Right,
so
you remember
get
that?
a cup of water.
Mm-hmm. Yeah, I have little bowls, but I gotta fill them up with a little bit of water. But for one of them will be used.
Oh, yeah, whipped cream and everything.
You can grab 1 graham cracker. You'll need, yep, and then you can crack it in half. There's a line on the middle.
Yes.
Other way. Yep.
There you go. Don't.
Yep, so the long way down. Yep, perfect.
And they perfectly fit together.
I don't think I did it right.
Oh, that's all right. Here, take another one. I got a bunch.
You broke it into
You got
thirds.
crumbs. I don't.
Yeah, it's just some extra
Go this way,
crust.
Lumpa.
This way?
All right.
Oh.
So,
Well, I
I'll
did
do it on
that.
Lucas's
That's why I
desk.
broke it.
but for the first one we're gonna be doing is the convergent or the transform boundary. With our transform boundary, Austin told us, is they're sliding past each other. So if you put your graham crackers like so on your whipped cream, the transform boundary is going horizontally up and down, right? So if you lightly push them together and slide them back and forth very slowly and with a little pressure, what do you notice? Do you hear anything?
Cream comes through.
Yeah, a little bit. That
It's
mantle
like-
coming through a little bit, but what else do
It
you
breaks
notice?
it
What do you hear?
Like the sides.
You hear them what?
Scraping or something.
Yeah, you hear them scraping and
Oh,
scratching
jeez.
across each other.
Start to do it.
Yeah, so you hear that scratching across each other. So that transform boundary, those 2 continental plates, they slide past each other and they make that loud sound. And did you hear that one transform boundary in California, San Andreas, that fault line, that's where that earthquake happened. So if they're pressed together very hard and that pressure there,
I don't think it's
That's how you
meant to
get that
do.
earthquake.
I don't think it's meant to be like this.
you know you're doing it right. Just slide them back and forth. Don't press too hard, just. That's okay.
Oh.
Lift them up a little bit.
Then
then
you
try.
just-
Yeah.
And then-
Yep, so you got it, Joe. Do you hear it? Good, you hear that. You see in the plates or your graham cracker like cracking a little bit on the edges.
These are very hard to do.
All right, so that's your transform boundary, those sliding horizontally up and down, right? All right, so next, we lift them off the whipped cream a little bit. Hands will get a little messy, but that's okay. Separate them. You'll have your divergent boundary, which is next. Oh yes, please. Thank you. So your divergent boundary. So if you separate them, lift them off the whipped cream. You can put your whipped cream back in the middle a little bit if you can. Do you want to? There's some spoons here if you need.
Oh gosh.
If anyone needs
Come on,
to
pass them.
put their whipped cream back together.
This is how you do it.
That's good too. Yep.
Pass them.
Great. Perfect. You just put them back together. Like so.
They used to be together.
Oh boy.
Put them back.
I have a quick question.
Yeah.
So do all these, because this is all new to me. So
Okay.
do they all, so is there one that creates what we would think of as an earthquake? Is it divergent? Are they all earthquakes?
They all can, but like
Okay.
convergent, yes, they're coming together, but they're cracking when they meet. So when they come together, they're cracking.
Mm-hmm.
If they're two continental plates, so two plates on the earth, they'll come up together and crack and build a mountain range.
Oh, okay.
So that's like
Alright.
the Himalayan mountains we were talking about a little bit yesterday, where they come together. That's the Himalayan mountains, and they're continuing to grow because that plate's still converging.
Really?
Mm-hmm.
That's amazing.
Yeah.
Okay.
Pretty cool. And then if it's oceanic to continental, do you remember the oceanic to continental? What's that one plate doing, Grace?
It goes under it.
Mm-hmm. Yep, that one plate's going underneath, and the one plate's
Yeah,
coming
we're
together,
gonna
and that magma's coming up, building those underwater volcanoes in the trench.
Oh.
Mm-hmm.
Oh.
Yeah, and then the two oceanic, same thing. They'll come together down and build that trench.
Wow.
You got that trench in the middle.
Okay.
And then convergent is the one we're gonna do now. If you separate them, when you press them down, the magma, the whipped cream is gonna come up, building that magma coming up, which will have those volcanoes. Yeah. All right. So divergent. We're doing divergent plates. So we got our whipped cream back together. I'm gonna have you press down fully on the whipped cream with your two plates. Put them next to each other again.
Alright.
Yep. And if you press them down, what do you notice?
Matt shoots at the side.
What's coming up the middle. Yeah. Yep. And then when you
Mine's
separate it,
Mine's not coming from the middle.
yours is coming from everywhere. But see how it's coming right up
Yeah.
here, building that magma, right? And then when you separate it, you see that magma's coming up from that center. So what I was just saying, let me look up here. My magma's up here, and it came up, and it's spewing out. So those plates are separating. The magma's coming up, and we have those plates building the magma underground or on land, and it's building that magma coming up, which creates those volcanoes, right? Mm-hmm. You remember that from yesterday, the video? Yeah. Good.
All we need to do is put them. The only one that we have to do is just put them together.
Yep. So you can put your whipped cream back together a little bit if you can.
I don't think I can anymore.
No. Do you need a new graham cracker?
Yes.
All right.
Hey, at least I made s'mores.
There you go. All right. So for this one, I'm gonna come around with a cup of water, and you'll get a new graham cracker. Actually, I don't know. For this one, we're gonna get a little wet.
I'm gonna need a paper towel. This issue.
Thank you. All right. So the two longer sides of your graham cracker, once you split them in half, we're gonna dip into a cup of water. I'll show you. Wash your hands when you're done. Those are my other plates to the side. Split this in half. I'm gonna dip the end into water on just a little bit. And dip this in.
Oh, so it goes into
Mm-hmm. Yep. Great
Very
job.
Good kid.
All right. So do you want to do that?
sure.
Dip your two ends into the water.
Add some more cream.
Okay. All right. So I'll do this first. So you'll dip your two sides ends into the water. Dunk them in a little bit. Yep. Just like that. Perfect. You do the other one too. The same side for this one.
Can I do
Yep.
the water now?
And then you can just move those two graham crackers away. Yep. Okay. So dip. Turn them.
Turn them like
Yeah, this side you'll put in the water.
so like this.
Mm-hmm. Both sides. Perfect. Yep. Yep. Perfect. You put them back to where they would go. Awesome. Okay, and the water is just going to help us represent that pressure aspect because it's a little hard when you're pushing them together if they were not wet that they'll crack. So we're doing that convergent boundary. So you can set them like this. Your two plates.
Towards each other?
Yep.
Mhm.
So when Yep, the wet sides are gonna be facing each other. Okay, so when you slide them together, what are you gonna see? What do you notice?
Absolutely nothing.
Oh, your whipped cream went above them. But, yep. Do you see what happened with mine? What do you
Starting
notice?
to see it now.
Yep, good. What do you see?
Oh, I think I did the wrong
What
boundary.
happened? The two plates, what?
The two plates bended it over top of the magma.
Yep, so what was.
I did the wrong boundary.
Well, that's another one that we'll do in a minute. But that, you're right. So what happened, Grace? What are we creating?
The mountain.
Yep, that's creating that mountain range, right? The two convergent boundaries are coming together. They met and they're cracking and they're pushing up with that pressure,
I think I
creating
did
a mountain range.
it
Austin did the other convergent boundary,
by accident.
where that it's all right, where that one boundary went over the top of the other one. Do you remember what that was called? Starts with an S.
Submission.
Subverge.
Subduction.
Yep.
So then
Yep, good. Subduction zone, right? Where that one boundary went over the other one,
the
right?
more denser went on bottom.
Yeah, exactly. Yep. Yeah, great. The denser of the two went below and created that subduction zone, right? Looks like this. D. That's the other form of that convergent boundary, right? Where the one plate's going this way and the denser plate's getting pushed down like that. Right, you remember that?
Yes.
Cool. Alright, yep, so that convergent made that mountain range that got pushed up. The
Okay.
other one, like Austin did, the one plate slid over the other one and the other one got pushed down. That magma got stuck in between the two, right? And it's creating that oceanic trench where those underwater volcanoes go. Awesome. Great job.
Can I wash my hands now?
Yes, you can wash your hands. You're all good. And if you want, you can eat the graham crackers. There's more graham crackers over here if anyone wants. You can add them to your plate. But
You can wash your hands. Yeah.
yeah, if you want to wash your hands, you can go wash your hands.
I got the door. Wait for me.
Oh, yes.
He goes, I don't know, I just. Totally. That convergent one worked perfectly.
Yeah.
With the water.
Mhm.
That's awesome.
I know, I saw it, that it was the one like person I saw that did it. She's
Yeah.
like, if you add, I saw a tip in the comment. She's like, if you add water to it, it works way better. I'm like, okay, good.
Yes, it worked perfectly.
Mm-hmm.
I never knew that mountains are still growing.
Yeah,
I
it's
had no
creepy.
idea.
Yeah, I watched one of the videos that I showed them yesterday. And it said that the Himalayas are like still growing
Yeah.
slowly, but
It's bananas.
because
Oh.
Yeah.
Yeah.
I just thought they were, all done.
Yeah.
It was just,
I know.
Oof.
It's crazy.
Yeah.
I can't think about it. It's just like the space.
Yeah.
Nope.
And
I'm good.
It's great that you're teaching them this, 'cause I don't think maybe I did. I don't think I've ever learned this before.
Mhm.
Do you think you ever learned
Not in depth like this.
it?
Like in
Not
earth
even.
science, they kind of just like told you about, you know what I mean? But like nothing.
Mm-hmm.
Yeah,
yeah.
I don't think earth science.
Ours, I felt like it was all rocks. Like
Yeah.
sedimentary, igneous.
Yeah,
like, I
all
felt like that's all I
rocks,
learned
yeah.
about.
If you want more graham crackers, you can take some. 'Cause yours are buried, but you can still eat those ones. if you want to.
That's why I have some whipped cream on my hands.
Yeah.
I don't even like graham crackers.
No.
I mainly like the whipped cream.
No.
That's what it's all for.
Nobody's giving theirs a go? Joe.
Yeah,
I was just waiting to wash my hands.
Oh, nice.
and Lucas had to actually use the bathroom.
All right. So now we're going to be looking at a real life example of that transform boundary. The transform moves up and down. There's a current one in San Andreas, California. So it's all the way across the country.
Isn't it gonna be like very slow since it takes a while, or is it gonna be like sped up to like a few days at a time to see the progress?
Well, they're just gonna talk about it like a little documentary of it, not exactly it moving necessarily. But this is where a bunch of earthquakes have happened because this is an active plate boundary. It's right in California. All right, so we'll just watch a little video about it.
Is that it?
These giant gashes in the Earth are reminders of our planet's awesome power. They are fault lines, fractures in the Earth's crust, where huge slabs of rock slowly grind past each other.
Mm-hmm.
Most faults we can't see, but here in California, the San Andreas Fault is visible at the surface.
You can't have an earthquake without fault. And I'm standing right now on what is perhaps the most famous fault in the world, the San Andreas Fault, that extends from Mexico down south, way up to Oregon in the north. This is one of the few places in the world where you can stand with 1 foot on one tectonic plate and one on another. In other words, this ground here is attached to New York and Iceland. The ground here is attached to Hawaii and Japan.
The San Andreas Fault sits on the boundary between the North American and Pacific plates. It's called a strike-slip fault, a place where two plates collide and try to slip past each other. As these plates move or creep in different directions, sometimes they get stuck. The longer they stay stuck, the more tension builds and the bigger the eventual quake. In other places, the plates move smoothly past each other. These areas buckle as the Earth shifts. The changes are subtle. Roger Billum keeps track of these changes with his creep meter, a device that measures movement along the fault. A computer collects data every minute for a year. This jump in the graph tells him the Earth shifted about 5 millimeters in a couple of hours. A small shift like this can have huge consequences for us.
That might not seem much, 5 millimeters, but it's affecting a long section of the fault, maybe 5 miles long, involving millions of tons of rock. Now, it really doesn't matter here. This is a nice sort of field that aren't any people. But further north, this creep process and the things that are happening beneath the Earth are far more sinister.
The San Andreas Fault and its branches trigger more than 10,000 quakes a year. Sometimes the results are devastating. Just ask the people of Los Angeles or San Francisco. Over the last 2 decades, major quakes rocked both of these cities. Life goes on, but the risk remains. In an area this active, the next violent tremor could happen at any time.
All right, so that's an example of a real fault line. Obviously, there's more all over the Earth. But is there anything interesting that you found from this video that anyone wants to share? Anything? You don't have to, but I noticed Lucas was writing down some notes. What did you write down? Oh, one of these. Oh, good. Yeah. You know, our fault line. So the one that we just looked at is that transform boundary. And in the video it said that they're constantly moving, right? We talked about yesterday. We know those faults are moving, but we don't feel it, right? Because they're moving super slow, like the nail growth, right?
Mm-hmm.
So an example we had yesterday was they said the faults are moving like how fast your nails grow. They grow, but you don't notice it. So that's how the faults are moving, right? But they said if it gets stuck, they get stuck together at one point, that pressure builds up and builds up and builds up. And when the pressure builds up to a point and it slides, they slide quick, and that's when that earthquake's created, right? Yeah, so that's how that fault, the San Andreas fault line in California, that's how that fault moves. And that's how they've had earthquakes there before. Yeah.
I have one question.
What's up, Joey?
What year was this video made? Or that video?
Video? I don't know.
Here, go click click off the video? Yeah, like click off completely. Go back to another tab and then go right back into this one. And then go back into one of your slides that you had, and then go back into another one, and it'll reset the video.
Alright, here, I'll look for it after.
Okay.
We're gonna do one more thing, and then I'll look for it, okay? Alright, so on Classroom, if you pull out your Chromebooks, I posted a Google form you guys can do. It just has 5 questions on plate boundaries that you can just answer, and then we can go over it together after you're all done. Sound good? And let me know if you can see it on Classroom. I can see.
Is it the link on the Classroom?
Yep, that link. And it should pop right up.
Oh yeah, it's here.
It came up for you? Work? Okay, cool. Oh yeah, mine won't work. Miss Jacob, can you log into Classroom again?
Yeah, it's all in. Oh,
Classroom?
on this you mean?
Yeah.
Sorry.
Very good.
My bad.
I don't know, my user won't work. Yep. Thank you.
We tried. 5 weeks. We're still trying. Admin or IT. Good times.
I know, because it lets me do it on my Chromebook, but not on this now.
It's
This one.
great that you have an email address.
Yeah, they
It's
give
really
me
nice
the
of them
email
to
and the
do-
Chromebook and everything.
Wow. Oh, you have a Chromebook?
Mm-hmm.
Wow.
Alright, so this is the Google form, it should pop right up. And then we'll go over it all together once everyone's ready. We just gotta wait for Austin to get back into it. It works for you, Joey?
Yeah, I don't
Okay,
know
good.
already else.
Does anyone have any questions on any of this? The Google form was okay? Not too hard? Okay. How's it going with it in science class?
Not bad.
Good? You enjoy it?
It's fast though.
It's fast,
Like
yeah.
if you miss one day, you forget everything.
Yeah.
If you miss one day, you miss a lot.
Oh, yeah. What did you learn about today in science? What did you talk about?
Oh, we just watched mainly videos. That's really very much it.
Oh, okay.
So
You got your slides, and now your slides you'll be able to do your plate boundaries, because we just talked about it today. And the slides that I created, I posted on Classroom. I don't know if you saw them, but that can help you with your slides for science too. All those definitions are in there too, so that can help you with the pictures. We have Austin like in there in a minute or so. Maybe he's not back then. I'll just show him up here. Do you like the graham crackers?
yeah, it is.
Are you a plain or a cinnamon fan?
I didn't realize you were
It
cinnamon
depends
until
on
I
what
ate them.
these ones were.
Or until I touched them.
These ones
Cinnamon.
are good.
Cinnamon.
Yeah, these ones are good.
Do you like the cinnamon ones?
It's like cinnamon toast crunch.
I don't usually
That's what
eat
I think
them. I don't usually eat them like by themselves.
Oh.
I just feel like it's too much cinnamon.
Mm.
But then I just ate it and I was like, oh, it's cinnamon.
Yeah.
I feel like these would be better than Oreos because you have to wait like a solid minute for Oreos to be like soggy.
Mm.
But these
Well, you
you
just
just wait
milk.
like 3 seconds.
Yeah.
Work
Yeah.
well for the right
Yeah.
the purpose.
Also went. but if you go in classroom yesterday, my slides are right here. So you can all go through. And we went through yesterday's, which was 1, and then today's, which was 2. And then we'll do 3 and 4 the rest of the week. You have all those videos and stuff.
Does anybody know the last one?
I went to the bathroom, but. If not, we'll just do it. So I want to go. Should I just do them? Okay. He can do it, and I'll show him after school or something. But all right. So plate boundary. So who wants to read number 1? Go ahead, Joey.
What is a boundary called when plates separate? Parentheses move apart from each other.
Awesome. All right. Which one did you pick?
I can't look at my things.
Plates are moving.
Divergent.
Great job. Yep, they're separated. They're moving away from each other. You can see with the arrows. You see that magma's coming up right there, right? We did with the whipped cream. Perfect. Great job. Okay, number 2. Anyone want to read it? Or do you want me to read it? Go ahead, Joey. You want to go again?
What is the boundary where the plates come together? Parentheses collide.
Awesome. So what is the boundary where the plates come together? What'd you pick? Go ahead, Lucas. Convergent. Awesome job. What's the plate? What's happening in this one? What is that? Is that subduction? Yep, that subduction zone where the one plate's headed under the other one. Great job. Okay, question 3. Does anyone want to read it? You want me to? You want to read it, Grace? Go ahead.
What is the boundary where the plates slide past each other?
Which one did you pick?
Yeah.
Yeah, great job. Yep, transform boundary. That just like that video we just watched, that one in San Andreas, California, where the 2 plates are sliding past each other horizontally. Great job. Okay. Question 4. Anyone want to read it?
What?
Go ahead, Joey.
Plate boundaries have an effect on the Earth's surface.
True or false?
True.
What do you say?
I wrote
or false?
true.
True? Cool, yep. Plate boundaries have an effect on the Earth's surface. Like again, in that video, the effect is an earthquake, right? Or another convergent boundary where the Himalayas are building. That has an effect on the surface, right? Yeah, great job. Okay, last one. What type of boundary is a San Andreas fault? This is just a picture of it in the United States. It goes all the way from here, cuts through California to Mexico even. So what do we pick? What kind of fault is it? Or boundary? Lucas? Transform. Perfect, yep. I don't know if you noticed with the arrows right there, sliding past each other. Give you a little hint. But yeah, great job.
Thank you.
And then I have all of those. I don't know if you can see your results on yours.